Hello viewers, hello learners. My name is Stembele Matoti. I come from St. John's College. I'm a geography teacher, but today I want to talk to you more as a deputy chief marker in the examinations. And I want to check if you know how to work to your favor in terms of how to answer the question paper in the final exam. Today's lesson will be on geomorphology, particularly focusing on drainage density and stream order. Welcome to the Eastern Cape Department of Education broadcast channel. Let us get started. The concepts to master when you are dealing with drainage density, let's start there, is the actual definition of drainage density. You have to be able to describe drainage density. And upon drawing, you should also be able to tell whether the density is high or low. So let's see. What is drainage density? It is the total length of all streams in a drainage basin divided by the total area of the drainage basin. So you add up the length of all the streams in the basin, then you divide that by the total area of the drainage basin, okay? It's a measure, maybe a different approach to the definition. It's a measure of the total spacing between the streams or the distribution of the drainage ways of the river. So this is a concept that I cannot prescribe on how to answer it word for word, but you must be able to give me an understanding that you understand that it's the drainage basin and the density of the streams inside the drainage basin. The next concept, runoff. Runoff is the movement of water through the ground to reach a body of water, okay? The movement of water through the ground to reach a body of water. This can be direct, as in you can see the river in the valley, in the stream channel, running maybe to a lake, maybe to reach the sea, but it's something that you can see. That is more on the surface and direct. However, there is indirect runoff that you can see, like groundwater, maybe running underground and hitting the sea, or coming up maybe and feeding the rivers from the bottom of the channel. So be aware that runoff can be direct, it can also be indirect. And then there's infiltration. Listen to the way I say it. Infiltration, okay? So the earth or the soil acts as a filter. When the water moves through the soil and rock layers to be stored as groundwater. So infiltration is a process where the water moves through the soil and the rocks to move to be stored underground. Now, this is going to be called groundwater. It's not underground water because it is underground. Yes, it is there, but we call it groundwater, okay? Very important. Now, what are the factors to consider when we are looking at drainage density, okay? We'll go through them, try to explain a little bit, okay? The first one is the amount of rainfall, okay? You'll always be talking about the average amount the area receives per annum. So it's an average amount of rainfall, okay? Is the average high or is the average low? Because the amount of rainfall has a part to play in determining the drainage density, okay? So if the average rainfall is high, it does tell you the amount that falls and also speaks to the actual density that you will find. And if the average amount of rainfall is low, it also speaks to the density that you will find. We'll deal with that a little bit later. Right now, I just want you to understand that This is one of the factors that you must consider. Okay. The second one, type of rocks. Okay. Meaning we are looking at the underlying geology. Okay. What you find below the surface of the earth. Okay. The underlying geology. Now, in that situation, I don't necessarily want you to name the rocks, classify the rocks, that kind of detail. But for purposes of this discussion, I would love you to understand that there are permeable rocks, meaning rocks that allow water to pass through them. And there are impermeable rocks, rocks that do not allow water to pass through them. So, what you need to consider in your mind now is if the area has got underlying geology that allows water to pass through it, it means it allows water to infiltrate. Okay? And the more the infiltration, the lesser the runoff. Okay? However, if the rock is impermeable, meaning the rock itself does not allow water to pass through it, it means the water cannot infiltrate, it cannot penetrate and sink to the depths of the earth, meaning there'll be less infiltration. Understanding? The lower or the lesser the infiltration, the more the runoff. That also speaks to the type of drainage density you will get, and we'll be discussing that a little later down the line. Number 3, amount of vegetation. Okay, vegetation can be in any form: tree plantations, bushes and shrubs, anything that will appear as green on your map, or that will appear as the key vegetation on your figure or drawing or any form of illustration. Please consider us to be referring to that, the amount of vegetation. Okay, think about it this way: is the vegetation more in this area, or is the vegetation reduced? Because the more the vegetation, okay, the more the infiltration. Because vegetation actually absorbs water, okay? And the same principle we dealt with before. The more the infiltration, the lesser the runoff, okay? Or is the vegetation less, okay? Meaning you have less of the green that you find there. Then in that situation, if you have got less vegetation, it actually means less water will be absorbed and more water will be run off, okay? Will be run off on the surface, okay? So in that situation then, think about it. If you have got more water that runs off, what kind of drainage density are you going to get there? Versus a surface where there is more vegetation and less runoff. So these are factors for you to consider. Lastly, I'd love you to look at the type of soil. Okay, the type of soil. Now, if you've got sandy soil, you obviously going to get you are obviously going to get more water that will be absorbed because the soil is sandy. However, quick fleet, loamy than to clay. Clay, the particles are compact and very, very close together and do not allow water to penetrate and infiltrate. So if the soil is clay, it means then you'll have less infiltration and more runoff. And that also speaks in essence to the concept of where you have more runoff, what's going to happen to the drainage density? If you have got less runoff, what's going to happen to the drainage density? These factors you must juggle in your mind, because the examiner can throw you this curveball when in fact he actually wants you to think deeper and articulate what happens at the end of the question. Another point, which I find very, very humorous sometimes, in the hassle of responding in the exam, when learners sometimes talk of vegetation, you find them talking about vegetables. Please, learners, don't be in a rush in the exam. Read and answer. Just pace yourself well and make sure you articulate your content very, very well. Okay? Let us see. That's a common figure that you get in the exam. Okay? You do find it in the control test as well, media exam, but there is a chance that you might also find it in the final exam. So we will deal with this, okay? Now, what are we seeing here first? What are we seeing here? We are talking about drainage density, okay? And we have one stream that is hypothetical, where we have tried to show you both high density and low density. What do you see? Because I don't want you to approach it very technically at first. Just look at what we see now, okay? Here we have got high density. And what you see above that line is what is high density, okay? What is it that we see here? We see a stream that has got many tributaries, okay? We see a stream that has got many tributaries. Look at this one. Tributary, there's the other one coming down, getting bigger, obviously, because the more tributaries that join, the bigger the volume of water. Look at that, okay? Look at that. And there are more. And you can see I'm only dealing with one segment of the stream. Already we have got close to 10 tributaries, okay? Now, compare that with the part below, where the tributaries are few and far apart. So the top part of the stream has got a high drainage density, and the lower part of the stream has got a low drainage density. What do we mean by that? High density, it means you have got more tributaries and more streams in the drainage basin, okay? Remember, it's the total length of the streams, okay? All combined together, then divided by the drainage basin in terms of area. Now look at the low density, okay? Few and far apart, okay? We have dealt with that one, okay? Few and far apart. Just trying to fetch my pen. Few and far apart, okay? Look at that. Look at that. At face value, whatever you see here, you will notice that this part here has got a high density. Many tributaries. This part here has got a low density. Very few tributaries. I want to link this concept to something else, okay? Sometimes when we talk about drainage density, we link it to texture, okay? So the higher the density, the finer the texture, okay? And the lower the density, the coarser the texture. Just keep those concepts in mind, okay? Now let me get my eraser because I will need this space. Okay, there we go. Now, what I also want to come to as well is when this question comes up in the exams, you will never be asked about density in a standalone kind of structure. There'll always be something to compare. For example, here I'm saying compare the top part of this image with the bottom part. Then you can see clearly that the top part has got a higher density because it's got more tributaries crammed together like that. And the lower part has got a low density because it's got fewer tributaries. So you have to be able to compare. You can't just tell off the thumb that this is low, this is high. We always have something to compare with. Let's take the next step. Okay? Now, in the event you got a high drainage density, what determines that? Okay? You've got a high rainfall. Remember I said, consider the average rainfall, okay? It's a high rainfall area, meaning there's plenty of rain, there's plenty of water, hence the runoff collecting into streams and forming the many tributaries. There's just plenty of water, very high average rainfall, okay? And then the second one, impermeable rocks, meaning rocks that don't allow water to pass through them. Because they don't allow the water to infiltrate, and therefore the water tends to run off on the surface. Okay, the lower or the lesser the runoff, the more the infiltration. The lesser the infiltration, the more the runoff. So you've got to be able to juggle these concepts because that's the nature of the question and the factors that you need to consider. Okay, and then we look at relief. Okay, there's relief, meaning topography. Okay, topography. Steep slopes. What do we mean there? The steeper the slope, the more the runoff. Okay, so if you've got a very steep gradient, it allows water to run down very, very fast. Okay, and it gives it very little time to infiltrate. Okay, so there'll be a high density of streams. The drainage density will be very, very high because water runs down the steep slopes. So it may maybe be termed differently, say steeper gradient, okay? Or topography is steep, or relief is steep. So be familiar with those terms, okay? So the steeper the slope, the higher the drainage density because there'll be more runoff, okay? And then we take the next one, less vegetation, less vegetation. So you have got less trees, less grass, less bushes and shrubs, nothing to absorb the water. What will happen there? There'll be less infiltration, meaning the lesser the infiltration, the higher the runoff. So more runoff always leads to a high density, okay? So less vegetation leads to a higher density. Now, this concept is possibly the easiest one to understand by now because we have harped on it quite a lot of time, okay? Less infiltration. Less infiltration here speaks to also the impermeable rocks. It also speaks to maybe the type of soil because when you have got clay soil, there'll be less infiltration, okay? What you need to understand here is the lesser the infiltration, the more the runoff. Hence, we have high drainage density. Let us move on to the next one. This one sounds more like the opposite of the top one, okay? Sounds more like the opposite of the top one, okay? Where there's low drainage density, you'll actually find that there's also low rainfall. There's no resource, there's no water. The rainfall is less. So you can't have the water that must run. It's minimal. The average rainfall is low. So you don't have the water to create a higher density. So the lower the rainfall, the lower the density, okay? The second one, permeable rocks, okay? The rocks actually allow water to pass through them, okay? There is permeability, meaning there's more infiltration. So you will not be able to get a high density because there's more infiltration and less runoff, leading to a low density, okay? Then the third one is a gentle slope, okay, where the gradient is very, very low. Now, the gentle slope actually equals poor drainage because it means the water cannot run on the surface fast and create more streams. So if the slope is gentle, the water cannot move fast, and therefore the drainage density will actually be low, okay? Lots of vegetation means lots of trees, lots of grass, lots of bushes and shrubs. What does vegetation do? Vegetation traps the water and absorbs the water. So what it means is there'll actually be more infiltration and less runoff. And therefore, with less runoff, there'll be low drainage density, okay? And again, more infiltration. If you look at the top part, there's less infiltration. But bottom part, more infiltration, meaning there is more water that actually is absorbed to the depths of the earth. And therefore, there's less runoff, leading to a low density. Those are the factors that you need to consider with each part, the high drainage density and the low drainage density. Okay, let's move to the next one, stream orders. Okay, we order the streams in geography, particularly in geomorphology. Okay, so the concepts that you need to master here are: number one, the source. Okay, the source of the stream, yes, always in the upper course, is where the stream starts. Okay, and the confluence is the second concept, where two streams join, they come together. We call that the confluence. Okay, those concepts must be mastered. Okay, now, in terms of stream order, all the first order streams, meaning your source streams, are going to be called fingertip streams. Okay, so your fingertip streams, you label them as one because they are the first order. Okay, now there are principles that we apply when we do stream ordering. Okay, for example, you label the fingertip streams one. Let's see, look at that. All the fingertip streams are labeled one. Okay, now here is the principle that you need to master as well. Two streams of the same order produce the next order. Okay, so if stream ordered one has got a confluence with another stream that is ordered one, they are two streams of the same order. They produce the next order. So after one comes two. So it's the next order. Order one, then order two. So look at this. This stream here, they join. And where they join, they produce the next order. Okay? So stream order one plus stream order one produces the next order, which is stream order two. That's the principle you need to master. Okay? Two streams of the same order produce a higher order. Okay? However, two streams of unequal order retain the higher order. So if there is a confluence where there is stream order 2 coming together with stream order 1, we retain the higher order, which means the 2 plus the 1 will actually equal 2, because 2 is the higher order. Okay, let's see. Look at that. Okay, now 2 and 2 produce the third order, which is the higher order, because 2 and 2 are the same order. Two streams of the same order produce a higher order. However, look more on my right. You'll find that there will be 1 and 1 there from the top, producing 2, the 2 in red. Learners, let us now get to master this addition part of it, okay? Fingertip streams 1 coming together with another fingertip stream, which is 1, produce the next order. Look at that, okay? That's 1 and 1 coming together and producing the next order, which is 2, okay? Now, let's wrap our heads around this. 2 streams of unequal order retain the higher order, okay? So there's your second order stream coming together here with a first order stream, and we retain the higher order, which is a second order. There you still have second order, confluence, first order, retaining the second order. However, where 2 streams of the same order come together, we get the next order. There's your second order stream, meeting your second order stream and producing your third order stream, okay? Now, if you have got the 3, which is the third order stream, coming together with another 3, 2 streams of the same order, they produce the fourth order, okay, which is a higher order. Now, this is a bit confusing to some people because they treat it more like mathematics, and this is not mathematics. we call it geo-adding. Okay, so 1 plus 1 will produce the next order, which is 2. 2 plus 2 will produce the next order, which is 3. Okay, so now you can see it's not your normal mathematics. Okay, now look at this. 3 plus 2, unequal order. We retain the higher order. 3 plus 2 produces 3 because 3 is the higher order. Okay, same applies. Look at 4 plus 3. 4 plus 3 is 2 streams of unequal order. We retain the higher order, which is 4, and so on. I hope you understand this, my dear learners. It's usually carrying 1 or 2 marks in the exams. Okay, now I just want to harp on something here. I want to link the drainage density with the stream orders. Okay, now here's the principle and here's the link. Okay, the higher the drainage density, okay, the higher the stream order, because you've got more tributaries. Okay, and those tributaries come in as fingertip streams, and more tributaries join to produce the next order. So the higher the drainage density, the higher the stream order. Okay, now let us look at the question paper. I'm not going to be doing all the questions here, but I just want to highlight something to you. Okay, for example, let us look at 2, 3, 4 here. 2, 3, 4. Okay, that refers to figure B. Okay, it says determine the stream order at point 1. Okay, now point 1 is here. Point 1 is here. Okay, there it is given. Now, if you put the labels correctly on the tributaries, okay, this is 1 and 1 producing 2. 2 plus 1 produces 2. Okay, 1 and 1 produces 2 here. 2 plus 1, 2. 2 plus 1, 2. And then you've got 2 plus 2 here. Here it produces 3. That's why we're talking here about the stream that is the third order. So you are free to write third order or just write 3 in the exam. Okay, maybe we'll get more examples. Okay, now let's get to the next question. Choose the correct word between the brackets to make the statement true. Okay, the higher the stream order, we've just dealt with that, the higher the drainage density, because you've got more tributaries joining together to produce a higher stream order. Let's look at the last one for this page, 2, 3, 6. Refer to drainage pattern B. Again, we are referred to B there. Okay, and describe the relationship, meaning you have got 2 things to talk about. Okay, there's a relationship here between drainage density and low rainfall. Okay, drainage density and low rainfall. Okay, now look at this. The low rainfall will result in low drainage density. Remember I said low rainfall, there's no water, so there's no question of having many streams. You can't have them because the resource is not there, the water is not there. Okay, so the low rainfall will result in low drainage density. The lower the rainfall, the lower the density. Whichever way you put it, we will understand it. Okay, look at B. Drainage density and steep gradient. That is the slope. Okay, that is the topography. That is the slope. Okay, the steep gradient will result in higher drainage density because the steeper the gradient, the more the water runs through and less infiltration. Okay, so the steeper the gradient, the higher the drainage density. Now, that's just about it on this question paper. That was November 2021 for your revision. Okay, now we'll take this one and quickly fly through it. Okay, now I don't want us to look at drainage patterns at the moment. I want you to look at 2, 3, 4. Okay, here, 2, 3, 4. The drainage density in B, there's B. Remember I said to you, you'll be given 2 figures and you can start comparing. Okay, the drainage density in B is, look at A. very few tributaries, very few streams, okay? And B, more tributaries. So the drainage density at B is actually higher because there are more tributaries, okay? So if you look at this here, it will say high, okay? Say high. And then let's take the next one. Determine the stream order at X, okay? There is X, okay? Now with the practice that we have done already, you'll be able to put 1 and 1 together, first stream, and then first order streams, and then you get a 2, which is the next order. Where you get unequal order, you retain the higher order. So the expected answer there is 4th order, and that is 2 marks. Easy 2 marks, learners, okay? Now, let's look at the next question. 2.3.6. Explain the relationship between stream order and drainage density. This question paper is from another year, but you can see it is very, very similar to the one that we have looked at, okay? The higher the stream order, the higher the drainage density. There's a relationship there, okay? Now let us look at 237, which is the last question here, okay? Explain how the slope, gradient, topography, and, which is now the second one, permeability of the underlying rock influence the drainage basin in density B, okay? Now, the marking guideline says the steeper the slope, the more the runoff, okay? And therefore, the higher the density, okay? It cuts more river channels, okay? And then in terms of permeability, rocks with low permeability, meaning they are impermeable, they don't allow water to pass through, have got more runoff. More runoff, the higher the drainage density, okay? We have come to the end of our lesson, learners. You can leave your questions on the comments box. Don't forget to leave the name of your school so that we can give a shout out, okay? Please share, recommend, and subscribe to our YouTube channel, ECDOE Broadcast Studio. There'll be more lessons for you to watch there, okay? Thank you for watching. See you next lesson. Remember, study hard. It's your last opportunity at grade 12, okay? The warmer the blankets, the colder the future. Thank you very much, and good luck for your exams. Thank you.